This video will cover all of the key features of graphs, looking at both X and Y intercepts, your different intervals where the graph is increasing or decreasing, relative extrema, which are really just any minimums or maximums, and domain and range. Make sure you are following along and taking good notes on your paper. So I want to start by just introducing in general what each of these are. So X-intercepts are where the graph is going to cross your x-axis. So you would have one X-intercept over here and one X-intercept over here. Those will be written as an ordered pair with whatever that x value is, comma 0. For your Y-intercepts, those are going to be wherever the graph crosses the y-axis. There should only be one of those for your functions. You may run into things later that have more than one. And those are going to be also written as an ordered pair as a coordinate point where the x value is 0, and then whatever that point is where it crosses will be your y. Your relative extrema are going to be any minimums or maximums. So wherever you have like turning points in the graph. So up here, this would be a maximum. You'd have another maximum down here. And it looks like right about the same spot as that y-intercept, there is also a minimum. So those points can show up twice. Both of these would be written as a regular order pair with whatever the x and y value are. When you're looking at a parabola, which we've done several times, you only have one, and that's like that vertex. Or going up, it's that bottom vertex. But those are called relative extrema. Your intervals of increase and decrease. So intervals of increase is wherever, as you go from left to right across your graph, just like you read, wherever the graph is going up. So I'm going up on that piece. I start going down, so I become a decrease, but over here I'm going up again. So those would be my two intervals of decrease. My two intervals of increase. My intervals of decrease are where they're going down. And when you are looking at those, you are looking on the x's. So, and those would be written like from, just as an example, maybe -2 to 0 is where it's decreasing for that one interval right there. Next we have domain and range. Domain are all of the x values that are covered, whereas range are all of the y values. So looking at this graph, it keeps going down in both directions, but as it's going down it is getting wider. So it would cover all the way to negative infinity and all the way to positive infinity, like every single x is going to work. So that would be all real numbers. Whereas for your y values, it never gets higher than this guy right here. And just right now we're going to call that value c. So that would be all real numbers that are less than or equal to c, because it's everything below that. And we'll do some examples with this as well. That's a general overview of what each of those are. So finding key features from a graph. First off, we want to look at the intercepts. So my x-intercepts are where they cross the x-axis. This first one here is at -4, 0. The next one is at 1, 0. And then this last one is at 6, 0. As I'm clicking through these, make sure you are writing them all down, pausing as necessary to get good, complete notes. For the next one we look at, it's your y-intercept. So that's this point right here where it's crossing the y-axis. Those coordinates would be 0, 2. Your relative extrema are any minimums or maximums that you see. So let's see, I did minimums first, it looks like, is how I listed it. And it doesn't really matter which one you do first. This is a minimum, and those coordinates are 4, -2. Whereas this guy up here is a maximum, because that's the highest it gets in that little region. So that's -2 to 4. Your intervals of increase and decrease, so I'm increasing, starting off. So that interval, I start off by increasing, and as I work backwards, that would be like all the way from the very beginning of time, negative infinity, up until this point right here. That maximum, I'm increasing. So that's negative infinity to -2. I then turn and start decreasing. So I'm decreasing, and again, I'm looking at my x values from this x value of -2 all the way through this y value of a positive 4. That whole interval, my graph is going down. Then I start increasing again, and I'm going to keep increasing forever as my graph continues. So that's going to be another increasing going from 4 to infinity. Finally, we're going to look at domain and range. So since this graph keeps going forever to the left and forever to the right, it never stops, there's never any holes or anything, your domain is all real numbers. Your range, I can tell here, it goes down forever and ever and ever. Even though it turns here, it does at the end end up going up and up and up forever, so my range is all real numbers. And you can write it like that, or you can really write out all real numbers. Now this was a nice pretty graph where everything was whole numbers and it was super easy to read off of the graph. It's not always that easy. Sometimes it's going to require you to use a graphing calculator. So for this next one, we are going to need to use our graphing calculator. A few things to remember. When you want to start your graph, you need to start by hitting your y equals button. So I'm going to hit y equals. It's going to pull up this screen, and I'm going to type in my equation. So I'm going to type in x, and you can follow my cursor over here, squared plus 2x minus 4. Once I have the equation written in there, I need to hit graph so that I can actually see the graph. When it's time for me to start finding some of these key points, I'm going to use second and then the trace button, and that will actually open up my calculator or calculate menu. So second, trace. The very first thing we have going here that we want to look at is an X-Intercept, so that's called a 0. So I'm going to go down to option 2 and hit enter. The first thing your calculator asks is for your left bound, and if you look, I have a little blinky cursor. I do have 2 X-Intercepts. I need to find both of them. I'm going to start with the left one just because I want to get used to always doing things from left to right. So I'm going to use that little left arrow, and I'm going to move my little blinky cursor guy all the way past this X-intercept, not too far past, but a little bit past, so that it kind of creates a barrier on this left side that I can't go past that when I'm looking for my X-intercept or my 0. For right bound, I need to move the little cursor over to the right past the X-intercept I'm looking at. I don't want to go all the way to the end. I just need to focus around this one X-intercept. I'm going to hit enter. When it says guess, it says somewhere between these two arrows there's an X-intercept. I want you to get your cursor as close as possible to that value and then hit enter. And it tells me that my X-intercept is negative 3.236068. So when I put that in here, I'm going to put negative 3.24. I'm fine with you rounding it. I want you to pause this and try to do that for the second X-intercept. We're going to that second calc menu again. For real, make sure you're trying it. Once you have, you should get 1.24, 0. For your Y-intercept, that should come straight from the end of your equation. You can look right here where it crosses the y-axis. You can even go second and then table and pull up your table, and you can see that where your x is 0, the y is negative 4. So I know that 0, negative 4 is my y-intercept. To find any relative extrema, minimums or maximums, so minimums are first, and there is a minimum. I'm going to go back to my second calc. I want option 3, because that's my minimum. And it does the same questions, left bound. So make sure that the blinky cursor guy is to the left of where that minimum is. It is, so I can hit enter. Right bound, I'm going to have to move mine over. But I just need to be the right of that minimum. Guess, get as close as possible as you can to where that minimum is. Whenever you see like the 0.9999999 or maybe a 0.000001, that's fine to run that. Like there should really be a -1, -5. So for my minimum, I'm going to list -1, -5. Looking back at my graph, there is no maximum. So when I ask for a maximum, there isn't one. You can just put DNE for does not exist. Your intervals of increase to decrease, I am starting this one going from left to right by decreasing. So it's starting by going down, and that's starting all the way from the beginning of time at negative infinity. It keeps decreasing all the way to this point right here that we just found was negative 1, 5. All I care about from that point is the x value, because I'm just going from left to right. My graph is going down all the way from the beginning of time until it became negative 1. So negative infinity to negative 1 for decreasing. As soon as it hits that x value of negative 1, it starts increasing, and it's going to continue to increase for the end of time. So my increasing value goes from negative 1 to infinity. In behavior, we're actually not doing, I just forgot to take that off. Domain and range. So domain is all of your x values. Since this graph goes forever and ever to the left and forever and ever to the right, your domain is all real numbers, and that's going to come from looking at your graph. For the range, it does go forever and ever up, but it does not ever go below this minimum point, this bottom point, which we've already found as being that negative 1, negative 5. Again, I'm going to y value is concerned with my range, so the negative 5 was the lowest the graph ever went for the y's. So my range is all real numbers greater than or equal to negative 5, because at negative 5 it works, and everything above that works. At the end of the page on the back, you should see some practice problems. Some of it's very broken up, some of it needs a calculator. Begin working on those.